In this lesson, we are going to explore how slope can also be considered a rate of change. And a rate of change is something that most people are familiar with, but they don't really refer to it as a rate of change. And a rate of change is a change in one quantity relative to the change in another. And this rate of change requires units, because units give this context. And the context allows us to take something that's theoretical and apply it to real-world situation. So one rate of change I'm sure everybody's familiar with is speed. And that in Canada is referred to as kilometers per hour, or the change in kilometers over the time in hours. Now when I graph linear equations, the slope, as long as it has units, as long as it has a real-world connotation, is also considered the rate of change. So how much is my dependent variable changing with my independent variable? So let's look at one quick example. I have a car and it's traveling 400 kilometers in 3.5 hours. And I want to know what's the rate of change of my car. So its average speed. So how fast has it been going over that 400 kilometers? I use the term average speed because I'm not sure how fast it was going at any particular instant, but I do know that over the 400 kilometers, it took 3.5 hours to travel that. And when I'm done, I want to graph the car's distance related to its time. So the first thing I want to do is I want to find out the rate of change. So just like anything else, I'm going to refer to it as the slope. Now, I'm going to take this down. My slope, in this case, is my rate of change. And that is going to be equal to the distance I traveled, which is my dependent variable, over the time it took. There we go. So in this case, I traveled 400 kilometers in 3.5 hours. And that gives me a grand total of, taking up my trusty calculator, 400 divided by 3.5 gives me 114.3, we'll keep significant figures, kilometers every hour. So that's my speed, 114 kilometers every hour. Now I can take this and I can graph it. Down here. So if I start right at 0, 0, because if I haven't traveled anywhere, there's no time, so I'm going to start at 0, 0. And my next point will be pretty much at 114.3. Actually, I have that reversed. Excuse me. So I have 1 hour, 2 hours, 3 hours, 4 hours. So after 1 hour, I know that I would travel, and I'm going to say this is 115, just to make it easy, kilometers. And I have another one here, 230, and that's how far I traveled in 2 hours. Then multiplied again by 3, I now have 345. That's roughly how far I've traveled in 3 hours, and so on. So I can take all these points together, and I can graph them. Use a ruler. So that gives me kind of my rate of change, and my slope is essentially my rise over my run. So my rise over my run. So that's pretty good. That's a pretty easy way to explain slope. It's a rate of change. I can apply it to real world situations such as distance over time. or other factors. So like price per unit, how much it's going to cost me to fill my gas tank, that sort of thing. It applies to all sorts of real world situations.